Hi guys, here's your chapter 3, section 2 lesson. I promise to do just a little bit better of a job than what I did the other day. So anyhow, we're talking about substitution with a system of equations here. So guys, what we're wanting to do is use substitution to figure out where these two lines cross. So here's your first example with substitution. The nice thing is, as you can see, in order to do this, we want one of the variables to be by itself, and in this case we do. Alright, these first couple examples are going to be nice, warm, and fuzzy. So all we got to do is if y equals this, equals 2x, then we're just going to plug this in for y. Alright, so all we got to do is take this and substitute it in for y. So now what we're going to have is 4x minus 2x equals 6. We combine our like terms to get 2x equals 6 divided by 2 and x equals 3. Now that you know what x equals, all we want to do is plug it back in to this original equation up here, and we'll figure out what y equals since y is by himself here. So we're going to say, okay, well y then equals 2. Instead of x, we're going to say times 3. 2 times 3 is 6, so y equals 6. So we want to write your final answer as an ordered pair. So the coordinate where these two lines are going to intersect is at 3, 6. And that's how we use substitution method. You can only deal with one variable at a time. Okay? So in this case, they set it up real nice for us. Y was already by itself. We were able to plug something in for y. We had the two x's, alright? So that's how we do the first one. We'll slide over here and look at this next one. Again, everything's all nice and warm and fuzzy because you see that y is already by himself. So all we got to do is plug in 4x where we see y in the other equation. So we're going to say, okay, negative 2x plus, instead of y, we're going to say 4x equals negative 4. Again, we're going to combine our like terms here. So negative 2 plus 4 is going to give me a positive 2x equals negative 4 divided by 2, and x will equal negative 2. Alright, so there's your x coordinate in our final, our final answer there. Oh well, try to get rid of that little black mark down here, but so we're going to have, that's not right either. There we go. X is going to be a negative 2. Now we figure out what the y is. And all we got to do is go right back up here to that equation. So y equals, now that we know what x is equal to, we just plug it in. Instead of 4 times x, we're going to say 4 times negative 2. So y is going to equal negative 8. And there's your ordered pair. Substitution is really, really easy so long as you've already got a variable by itself. Okay, so these first two in this example, pretty nice, warm, and fuzzy. But as you can see, as we stroll down here to the next example, neither one is by himself. You got x and y, x and y. I like to give this guy 1, you know me. So now you just choose a variable to get by itself. Okay. So, and again, like I was doing in the first section, I like to label these equation A and equation B. So, since this guy's a 1x by himself, let's solve for him and get him by himself. So we're going to take equation B then. So 1x minus 2y, I believe it should be equals negative 3. So we're going to add the 2y over, so we get 1x equals 2y minus 3. So x is now by himself. So now that we have the letter by itself, we're going to plug this part back into this first equation. So now I go back to my A equation. Again, I'm going to take this piece here and we're going to plug it in for that x right there. So now we're going to say, okay, 3, instead of times x, we're going to say times 2 times y minus 3. Then bring down the rest of the equation. Plus 2y equals 1. Okay. Now there's a little bit more work involved here, but such is life. So you're going to distribute. So now we're going to have 6y minus 9 plus 2y equals 1. I just brought the 2y and everything down. We have like terms here and here. So this is now going to become 6 and 2 is going to be 8y minus 9 equals 1. Add the 9 over, so 8y equals 10. And we divide by 8. I'm going to slide this over here. So y is going to equal 10 over 8. Alright. Which as a fraction that reduces to 2 goes into both of them. It's going to be 5 over 4. Or if you're graphing it, 1 1/4 is easy to graph on a grid. Okay, so that's your y. All right, now we got to plug it back in and figure out what x is equal to. So I'm going to go back up to not an original equation, but I'm going to use this part right here since I had x by itself, and I want to know what x is equal to. So we're just going to take this guy right here. All right, let's rewrite this. Actually, I'm going to shrink this and move off to the side here a little bit. You do whatever you need to do. So I'm going to say, okay, x equals 2, and we're going to say times 5/4 minus 3. So 2 times 5/4 is going to give you 10 over 4 minus 3. And x is going to equal 10 over 4 is actually going to reduce again to 5 over 2 minus 3. Okay. 5 over 2 is 2 1/2. So you're going to be left with a negative 1/2 for your x. Now these didn't come out too warm and fuzzy as far as numbers goes and values. So I'm guessing maybe up here in this example, again, we had a typo there, maybe something didn't quite come out right. But still, it's an ordered pair. So your x was a negative 1/2 and your y was 1 1/4. Okay, that's for example A. All right, the process is the same, even though our answers didn't come out too warm and fuzzy. But you see what we have to do. We had to get a variable by itself first, which is what I did here. Then plug it in, work it out, and figure out what the value is of one of these letters. Plug it back in and solve. Okay, substitution can be a lot of work. It can be a lot of work. It doesn't get any worse than what we've done right here, though. So let's look at example B. And again, okay, if I'm going to figure out who do I want to solve for, again, I see a letter, it's really by itself, it just has a 1, so I'm going to isolate this guy and get him all alone. And again, let me zoom in here. Let's call this equation A and equation B. So I'm going to take equation B, and we're going to solve for that y. So it's a negative 2x plus 1y equals 4. So all we got to do is add the 2x over, so we're left with y, or 1y, equals 2x plus 4. Now we go back and we take equation A, and we substitute our value for y. So we're going to say, okay, it's 3x plus 2 times, instead of y, we're going to say 2x plus 4, and this is going to equal 1. Now, everything here as far as algebra goes, you guys have done this before. It's no problem. Just distribute first. I'm just going to bring down this 3x. 2 times 2x is going to give me a positive 4x. 2 times 8, or 4 is going to give me 8, which equals 1. we're going to combine our like terms, which is going to give us 7x. I'm also, if you don't mind, I'm going to subtract this 8, all in the same shot. You guys are juniors. Okay, so we're going to have 7x equals negative 7. And we divide by 7, and so x equals negative 1. Now with that we know what the value of x is, we're going to use this to solve for y. Now again, I'm going to go back to my part where I already solved for y. I mean, why do extra work if you don't need to do it, right? So we're going back to this equation b right here, okay, where I had y equals 2x plus 4. So now it's going to be y equals, instead of 2 times x, it's going to be 2 times negative 1 plus 4. So y is going to equal, it'd be negative 2 plus 4, and y equals a positive 2. So, in conclusion, your ordered pair, the x was a negative 1, and the y is a positive, whoops, not 4. Almost screwed it up. Go back up here, right here. Come on, Mr. Brooks. Should be a positive 2. So where on the graph does do those two lines cross? They cross at negative 1 and 2. Okay, so that's example 2. And again, it's not going to doesn't get too much any more work involved than what you saw right there. Now, lastly, the word problem. Let's talk about this. Okay, you got on a particular day at the Henry Ford Museum in Dearborn, Michigan. They admitted 4,400 adults and students, and they collected $57,200 in ticket sales. The price of admission is $14 for an adult and $10 for a student. How many adults and how many students were admitted that day? So, let's identify important pieces to our puzzle. You need two equations, because we're dealing with, okay, let's call adults x. You know what, let me use a different color there. Let's call adults x, students y. Alright. And on this day, if I was going to write equation A, adults plus students, right, equaled 4,400 people. Does that make sense? I surely hope so. Now in our B equation, now we're talking about the price. It's $14 per adult, so 14x, plus $10 times every student, so 10y, and that's going to equal the 57,200, okay? Okay, so now you just ask yourself, okay, I need to solve for one of these variables by itself. Obviously, one of these two would be the best way to start out this problem. So, here's what we're going to do. I'm going to take equation A, and I'm just going to subtract the y. So I'm going to have 1x is going to equal a negative 1y plus 4,400. Okay? Now I've got a value for y, that's this right here. I'm going to plug it in right here. So we go back to our B equation now. And 14x is going to, or I'm sorry, we're not plug it in for the y. We found out what the value of x is. Moron. So we're going to plug it in right here. Sorry, guys. So we're going to go, okay, 14 instead of x, we're going to say negative 1y plus 4,400. Yes, you're going to need a calculator. Plus 10y equals the 57,200. So we distribute here, okay, and we're going to get a positive 14y plus, and I've got my calculator here on my phone. So 14 times 4,400, okay, that's 61,600, which is roughly my IQ, plus 10y equals the 57,200. So now we combine like terms. You got a like term here and here. these two guys you got to get together on the same side. So let's take care of the circles. 14y and 10y, that's going to give me 24y. And I got to subtract that 61,600 over. Okay, so I made a small mistake. See that little thing right here? Looks like a negative sign, doesn't it? And that's exactly what I thought it was. So I can't seem to erase it, so we're just going to splurge him out. So this should have been a negative 14y whenever I distributed here. Alright, so now as we scroll down, instead of having 24y, I don't understand why it never lets me do that, but we should have negative 4y. Alright, and then we have to subtract this 61,600 over. Alright, so when you subtract that, you're going to have negative 4y equals, if you take 57,200 minus 61,600, we get a negative 4,400. Divide by 4, now two negatives make a positive, so we get a positive 1,100. So that's y, and y represented students. So that's how many students came through that day. Now we need to figure out how many adults. Now again, go back to what you've already did. You need to know how many adults? That was x. X is solved for right here. So all you got to do is, let's scroll over here a little bit, and let's take this equation right here. So we're going to say x equals negative 1. Instead of y, we're going to say 1100 plus 4,400. So x equals a negative 1,100 plus 4,400. Do the math. I get x equals 3,300 people. So the adults, and I just label that adults, and down here you could label that students, and we're good to go. And that's how we do a word problem with systems of equations. But you saw how easily I got thrown off by a negative sign, or what I thought was negative, okay? You know, kind of summing this up, and sorry Joe Moody, this has taken a lot longer than I thought it might, but it's system of equations, man. It takes a while. Anyhow, like I said in the beginning, it's great whenever you have a letter already by itself, but as you can see, we got down here and they weren't, and it took a lot more work, and it takes a lot of organization. That's why I label things A and B. That's why it's nice to have plenty of room on your paper. Okay, so that's lesson 3.2, and we'll catch you guys later on. Bye. 18 minutes, 23 seconds, Joe.